Hello, and welcome to our lesson on convergence of divergence of series. Now we're going to start with an example. Assume you're 200 centimeters from a wall. You move toward the wall step by step, but each step takes you exactly half the distance, half the remaining distance. Write the sequence to represent the lengths of each step. So my first step, if I go half the distance, will be 100. My next step will be 50. The next step will be 25. The next step will be 12.5, and so on and so on. Notice how since it says sequence, I have a comma in between each number, where if it says write the series, I would put an addition sign between each number. What does the series created by this sequence represent? So the series, if I have 100 plus 50, that means I've traveled, if I start, this is the start, and this is the end, that means I've gone 150 meters. If I did 100 plus 50 plus 25, that means I've gone 175. So now it asks, how many terms are in this series? So how long is it going to take until I actually hit the wall? That's a tough question. Theoretically, will you ever hit the wall if you keep going half the distance, half the distance, half the distance? Can you actually ever hit a certain place? That's a tough question. Now, how many terms are in the series? There would be an infinite number of series, because if you can keep going theoretically and keep cutting each space in half. All right, so for this series, let's just do S of 5. Let's see what the sum of the first 5 terms are. Well, we take our first term, which is 100, times 1 minus my r, which my r is 0.5, to the n, which in this case is 5, all over 1 minus 0.5. So if I take out my trusty calculator, all right, now I have my trusty calculator open, so I'll do 0.5 to the 5th power, 1 subtracted from that answer, and then I multiply that by 100, and then I divide that by 1 minus 0.5, which is just 0.5. My answer is 193.75. So we're most of the way in just 5 steps. Now, let's do S of 10. 100 times 1 minus 0.5 to the 10th, all over 1 minus 0.5. So 0.5 to the 10th. See, now that's a really small number. 1 minus that number is going to be pretty close, 0.999. Multiply that by 100 and divide that by 0.5, and we get 199.8. All right, let's do S of 15. So we'll have 100 times 1 minus 0.5 to the 15th, all over 1 minus 0.5. So 0.5 to the 15th, subtract that from 1, multiply that by 100, and divide it by 0.5. 199.994. So now we're really close to 200. We could keep going and having our S sub some very big number, and it'll keep getting closer and closer to 200. So this asks what number does it appear that our partial sums approach? Eventually, they hit 200. And if I write this in limit notation, the limit as my n goes to infinity of my s of n is going to be 200. Now, let's think about why this is true. Now, in our example, 1 minus 0.5 to the n, as n gets very, very big, what happens to 0.5 to the n? 0.5 to the 1 millionth power is essentially 0. So then we would have 100 times 1 minus 0, which is 1, divided by 1 minus 0.5, which is 0.5. So 100 divided by 0.5 is going to be 200. Now, I shouldn't say that this equals. I should say as x goes to infinity instead of an equal sign. As x goes to infinity, this will get closer and closer to 0, and s of n will get closer and closer to 200. We call these divergent or convergent series, where the last one was divergent. Arithmetic sequences always diverge. We don't have to worry about them converging because they'll always diverge. Geometric series only diverge if r is greater than 1, or square root of r, or absolute value of r is greater than 1. The only time we have to worry about convergence is if the absolute value of r will be less than 1. I should actually say that it diverges if r is greater than or equal to 1. If r was equal to 1, then it wouldn't really be a geometric series. I guess it could be a geometric. It would be the same number. The series, I guess, would have an addition sign. So that's what happens if r equals 1. And this is not going to get closer and closer to one particular number. It's going to keep getting bigger and bigger and bigger. So I could have an or equals to there. All right, let's take a look at this. Let's first figure out if it converges or diverges. First, let's think about if it's arithmetic or geometric. If it's arithmetic, we'd subtract by 5. But if we subtract by 5 again, we'd get down to 40, not 40.5. So let's try to see what we multiply. What would I multiply to 50 to get 45? Well, I'd take 45 divided by 50, and I believe I get 0.9. And if I take 40.5 divided by 45, I also get 0.9. So those converge. Because the absolute value of r is going to be less than 1. Now, to what limit does this converge? Well, let's do our s of n. This is almost like an s sub infinity, because as this goes closer and closer to infinity, what happens? Our first term is 50 times 1 minus my r, which is 0.9, to the infinity power, all over 1 minus 0.9. If I take 0.9 to infinity, that's... All right, so now if I take 0.9 to the infinity, that gets closer and closer to 0. So this becomes, I should say it goes to 5 times 1 minus 0, which is 50, I should say, times 1, all divided by 0.1. So 50 divided by 0.1 is, we could probably do this in our heads, but just so you can see me type it in, 50 divided by 0.1, 500. So as we keep adding these numbers, they'll keep getting closer and closer to 500. Now, if we look at this series, is it going to converge or diverge? This goes up by 6, goes up by 8. So this isn't an arithmetic. If I divide these out, it's 24 divided by 18. Now if I multiply that by 24, do I get 32? All right, so we have a geometric series here. So we have a geometric series multiplying by 4/3. Now, is it going to converge or diverge? Well, absolute value of r is greater than 1, so it's going to diverge. And if you think about it, the number that we keep adding on the end still can be a bigger and bigger number, which means that it won't get closer and closer to one particular value. Now let's look at this. This goes down 4, down 4, down 4. Since it's arithmetic, we know it automatically diverges. Here we're multiplying by negative 1/4. Multiplying by negative 1/4, and so on. Since the absolute value of r is less than 1, because that would be 1/4 is less than 1, then we know it's going to converge. Let's try to see what this converges to. So if I do my s of n, it's going to equal my first term times 1 minus my r, which is negative 3. That's going to go to the infinite power. What do I have? That should be 1/4. Negative 1/4. And then we divide that by 1 minus negative 1/4. Well, this top one goes negative 1/4 to the infinite. The power goes to 0. So we have 48 times 1, all divided by 1 minus a negative 1/4. So that would be 1.25. So when I divide that out, I have 48 divided by 1.25. 38.4. If we look at this one, first, we don't even need to really see if it's arithmetic or geometric. You can see that this keeps going up by a bigger number, so that since it keeps increasing, we know it's going to diverge. And here's your homework. Good luck.